Assalamualaikum warahmatullahi wabarakatuh. Good morning. Thank you for the time and opportunity given to us. Through this video recording, I represent the team to present the result of the research in the form of a scientific article that we have submitted to TELKOMNIKA journal some time ago. Our article is entitled Comparison of Word Embedding Feature Using Deep Learning in Sentiment Analysis. The integration of data derived from social media marked a recent breakthrough, offering an alternative data source in addition to conventional data collection method. Data collection via social media is considered to provide efficiency in many ways. This efficiency includes the cost that must be incurred for data acquisition, being able to obtain data in real time, and producing data that has more detailed information to describe the true opinion of the community. The activity of analyzing public response and opinions using data source from social media is called sentiment analysis. Sentiment analysis, a subset of natural language processing, focused on employing machine learning method to identify and extract factual details from written text. His encompasses discerning the emotional nuances and determining the general sentiment, be it positive, neutral, or negative, conveyed by the writer. Implementing sentiment analysis on extensive textual dataset such as social media updates or user comment allow for comprehensive analysis. In natural language processing (NLP), computer lack inherent understanding of textual language, necessitating technique for converting word into vector to facilitate comprehension. The process of word vector representation remains a compelling area of ongoing research. This representation holds great significance as it profoundly influences the accuracy and efficiency of the constructed learning model. This word representation technique is included in the feature engineering section. Feature engineering in textual data has its own challenge due to the characteristic of unstructured text. The feature engineering strategy for textual data that is popularly used in known as the word embedding feature. This word embedding feature is collaborated with several classification methods. There are many types of classifiers that are commonly used to classify sentiment analysis. The methods that are often used are machine learning method and deep learning and extra. In this research, the types of methods used are deep learning methods, namely conditional random fits, bidirectional long short-term memory, and convolutional neural network. Conditional random fields are used to build probabilistic model for sequential data segmentation and labeling. Because it is conditional, CRF is also used to ensure that inference is easy to do and also avoid the problem of label bias. BSTM is used to fill out the previous information process and fill out the information process afterward. Meanwhile, CNN is used to see processing capabilities and evaluated classification performance on text data. We evaluated the efficiency of various classifier methods by testing their performance with different word embedding features. The types of word embedding feature tests are word-to-fact, GLOVE, and FASTTag. The experiment process was carried out on a sentiment analysis dataset taken from Netflix user comments. Netflix was chosen due to its dominant popularity in streaming services, large number of users, and variety of content offered, making it a relevant subject for understanding use preference of digital entertainment services. Observing use feelings, whether they are positive, negative, and can provide valuable information about how users feel about the service, experiences, and content provided. Based on the above problem, we conducted research as well as the contribution of this research, namely to improve the evaluation value of the classification performance of deep learning method, namely conditional random fit, bidirectional long short-term memory, and convolutional neural network by using word embedding features, namely word-to-fact, GLOVE, and FASTTag as technique to improve the evaluation value of deep learning classification performance on machine learning dataset on social media data from Netflix application user comment. Material and method. In this section, we use dataset obtained through a data collection process carried out by crawling. We utilize the Google Play Scraper Python library to crawl data. The application ID where the data will be taken is required first. In this case, Netflix has the ID com.netflix.media client. Furthermore, the selection of language in the review is an important step, where this study only consider review in Indonesia. After selecting the language, the selection of review is based on score. In this study, the review can have a score rank 1 to 5. Furthermore, the review order used is most relevant. The amount of data to be taken also needs to be determined. The data obtained has several attributes, including review, username, user image, content, score, thumb up count, review created present, add reply content, answered, and application version. However, not all of these attributes are needed for the study. Therefore, irrelevant or unused attributes are removed to simplify data. There are 4 attributes that will be used, namely username, score, date, and content. Then after we get the data set, we do the next, namely pre-processing. In pre-processing, we do data cleaning, scaffolding, tokenization, stop word removal, stemming, and labeling. Then we conducted 2 experiments. In the first experiment, we conducted the training and testing process using the deep learning method, namely conditional random fit, bidirectional long short-term memory, and convolutional neural network. Then calculated the classification performance evaluation value. Our second experiment, we conducted the training and testing process by using deep learning method that was injected with the word embedding feature. The word embedding feature that we use were GLOVE, word-to-fact, and FASTTag. Then calculated the classification performance evaluation value. Then the next step, we compare the result of 2 experiments above. Result and discussion. This section provides an overview of the outcome and deliberation stemming from experiment conducted according to the research framework outlined in the preceding section. The experiment revolved around the assessment of social media text data using a variety of deep learning method and wood embedding feature. With 80.20 split validation. The tests carried out in this research include deep learning testing with variation of wood embedding. Deep learning is a sentiment classification method for text data used in this research. The following types of deep learning method, namely conditional random fit, bidirectional long short-term memory, and convolutional neural network. For word embedding, we use three features, namely word-to-fact, glove, and fast tag. Next, according to the result of the three experiments above, the BLSTM algorithm achieved the highest accuracy rate of 79.5%, while the CNN algorithm yielded the lowest accuracy at 72.5%. Prior to incorporating any word embedding features, meanwhile, the highest accuracy result after using the word embedding feature were obtained from the BLSTM algorithm, with the word-to-fact feature with a value of 87.1. And the lowest accuracy was also obtained from the BLSTM algorithm on the glove and fast tag. After looking at all classification performance evaluation value, namely accuracy, precision, recall, and F1 score, the best algorithm is the BLSTM algorithm with stable evaluation result in all word embedding. All tests still tolerate false positive and false negative error. All algorithms still use the original parameter. This could be a gap for further research, such as reducing the value of false positive or false negative. The gap to improve accuracy can also be achieved by tuning all hyperparameter. One thing that needs to be noted based on the three images above, this is the result before using feature. The CNN value is the lowest, while the result after using feature are obtained from BLSTM with the word-to-fact feature. This could happen because the characteristics of the CNN are not compatible with text data. But after using the feature, the CNN value increasing significantly. Meanwhile, BLSTM has performance that is capable of reading the input data sequence from two directions, able to read text carefully, resulting in very good performance. Comparison of accuracy above explain that the best word embedding produced in this experiment is word-to-fact, which gives the highest value to the CRF and BLSTM algorithm. This is very in line with the way each method works. Word-to-fact can produce the best accuracy value because of the characteristic of word-to-fact, which is able to represent word into a vector and is very suitable when paired with BLSTM and CRF. Because the characteristic of BLSTM and CRF are compatible algorithms to process text data. Meanwhile, FastTag gives the highest value to the CNN algorithm. Despite not achieving higher score compared to BLSTM and CRF, CNN significantly benefit from the inclusion of FastTag. FastTag is able to provide in very significant increase because FastTag work based on a collection of consecutive words in a text document which contain word, number, symbol, and punctuation. Conclusion, Our research has highlighted the efficiency of pre-trained word embedding model in sentiment analysis. Through a sequence of experiments, we have demonstrated the capability of this model to achieve high level of accuracy across diverse textual dataset. However, one drawback of employing pre-trained word embedding for sentiment analysis is their reliance on a predetermined set of word relationship, which may not consistently align with the requirement of specific task or dataset. In our evaluation, various deep learning method with different word embedding feature were tested. With the BLSTM algorithm yielded the highest accuracy of 79.5% prior to incorporation of word embedding feature. Meanwhile, the highest accuracy result after using the word embedding feature are obtained from the BLSTM algorithm with the word to fact feature with a value of 87.1%. Meanwhile, a very significant change in value increase was obtained from the fast tag feature in the CNN. After looking at all classification performance evaluation value, namely accuracy, precision, recall, and F1 score, the best algorithm is the BLSTM algorithm with stable evaluation result in all word embedding. Suggestion for further research can be made to reduce type 1 error prediction result or the reduce of FP value. This can also be traced to a gap where increased accuracy can also be achieved by tuning or tuning all the hyperparameter of the classifier. That is the presentation that I can explain. I apologize for any mistake and shortcoming. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.